Hi, and welcome to this fourth and final video on the value creation system. And in this video, we will look at product development, which is explained further in chapter 7 of your course book. A lot of engineers end up working within companies with certain aspects of product development. It can be in terms of technological development or working with ways of improving the value proposition, improving services and with service innovation, for example. So that's a lot of engineers are working with product development in different ways. So if we look at the book definition of product development, they state that this includes all activities that contribute to the development and improvements of the company's value propositions. So it's a rather broad definition. You can work with either the, like say, physical goods, but also with services and service innovation within a company. And this chapter is organized similarly to the other two chapters in the value creation system, chapter 5 and 6. So you have a strategic level, and then you have tactical level, and then the operational level, which are discussed in this chapter. And I will try to explain these levels briefly in this video. So at the innovation strategic level, you have long-term issues such as innovation, strategic positioning, technology strategy and building competences, strategic product planning, platforms and derivatives, and portfolio planning. At the tactical level, the company deals with management, control, and coordination of research and development, as well as product development projects. And at the operational level, this chapter will introduce some methods and techniques to run product development projects more effectively and efficiently. So let's take a look at the strategic level first. So why is there a need for innovation? Well, this figure from your course book is basically describing how the sales volume will typically change over time for any or most products. So you have an introduction phase, and then you have a growth phase, and then a maturity phase, and a decline. And within these phases, you basically earn a lot of profit from your products. But when the decline starts, the profit margin will decrease, and over time, this will not be a profitable product anymore. So you need to balance this with new products coming in with new growth and maturity periods and so on over time. Otherwise, the company will not stay in business for long. So there is a constant need for innovation and product development within all companies, I would say. Um, if we talk about innovation strategic positioning, there's a discussion in the chapter which is about 4 different typical classes of positioning. So you could be a technological pioneer. If that's important in your market, maybe you will end up as a company developing a lot of new core technological innovations so that you can stay competitive at the market. So you can take a very offensive role as a pioneer. But you can also be a fast follower, which is a bit more defensive. So you may not take as many risks with high risk technological development projects, but you will follow fast. So you will monitor what's happening on the market, and you will integrate this within your company as soon as you can, and follow the pioneers, so to speak. Or you can take a cost minimization approach, which is basically imitating what's going on the market, imitating new technology, introducing it into your products, and try to make money that way at the market. And there is also this traditionalist, a very conservative approach, which will you will not take charge in developing very much new technology at all. You would be more conservative, monitoring what's happening, um, and trying your best to earn money anyway. Or you may be on a market that's not very innovative, uh, and there's not that much need for innovation also in certain markets. Um, okay, so let's talk briefly about the technology strategy. And this strategy is about how do we conduct research and development, R&D, within our company. We often discuss this, perhaps, that we should try to have core technologies developed in-house instead of outsourcing these types of technology development projects. There is a number of in this case, 4 classes of technologies described in the chapter. So you have core technologies, which are essential for the company's products. And these core technologies are oftentimes reasonable to try to keep in-house so that we learn how to use the technologies, and we may also need to develop them ourselves, so that we can use them in our products and we can stay competitive at the market. There's also complementary technologies, which are important but not unique for our company's product. So these may perhaps be developed outside of our company, at other companies, and we can license them in and so on. And then we have peripheral technologies which are important for the use of our product and for our business model, but they are not under control by us as a company. And then there are emerging technologies also. These are new technologies that may be important for the future, so we need to monitor them closely, but they are perhaps not mature enough to incorporate within product development in our company. The chapter also discusses platforms and derivatives. And this works in this way that you may have several separate products which are called derivatives that can be developed from one platform of core technologies. So you may want to think about the car industry, for example. Today, there's a lot of discussion about new platforms for electrical vehicles, for example, and these cannot be the same as platforms for cars with engines run by gasoline or diesel, for example. And from these platforms, you can develop several uh, different kinds of vehicles from the same platform, and even different brands from the same platforms. Another example is mobile phones. And I remember when I bought this phone, which is a Samsung phone, there were, I think, 3 different options with different prices for the same type of built on the same platform. And then there were different premium options and so on you can buy. But basically, this is an example of derivatives from one platform of core technologies. Okay, so let's look at the tactical level of product development. And in this subchapter, there's a discussion of the technology development process and the product development process. If we look at the technology development process first, there is an illustration in this chapter which is called the development funnel, which is very commonly used in this case. So the funnel, basically, in the beginning here, you have pre-development or scoping studies, and then you have product development projects going on here, and then here you have launched products. And this funnel basically describes that in the earliest front-end phases, it's quite wide. So you will entertain a lot of different ideas. Some of them will become pre-development scoping studies. And over time, some of these will be removed. They are not feasible or um, feasible to start product development projects. But once you come over here, the funnel is more narrow and you have fewer product development projects started. And even here, you can have some of these terminated due to some discovery that you have in your development project. But in the end, some of these product development projects, they will become launched products from which we can and these can be marketed on the market, and we can start to earn money on these products. The other part of that subchapter is about the product development process. And the product development process, it has a number of phases. So for example, you have planning and pre-studies in the early phases, and you have concept development, and you have system design, detailed design, testing and modifications, start of production. And the chapter discusses two competing ways of doing this. So there is there's a benefit of working with concurrent engineering, which is basically saying that some of these phases will be run in parallel, overlapping in time. And by doing that, we can shorten the lead time it takes for us to get the product onto the market. And this is competing with the traditional, let's say, sequential approach to development, which is more simple but takes longer time. So the concurrent engineering approach is definitely more demanding, challenging for the company, but is also quicker. So this is discussed in the chapter. You can also read more about this disciplined model to control product development projects, which is called the stage gate model. So you will have product development phases, which are called stages here, and these are ended by formal decision points, which are called gates. So for example, the steering committee will have a gate, which is an initiation of the feasibility study. And given that that decision is taken, the feasibility study starts. And at the end of this feasibility study, there's another decision gate, which determines if this is it's going to be a project. So then if that's a yes, then product assignment is started and the product planning starts and so on. So you have the stages and you have the gates here. And this is a common way of running product development projects to control them and to know where, at which stage these development projects are currently. Okay, so at the operational level of product development, this chapter discusses a number of methods or techniques to support the development of new products. For example, then visual planning, Obeya, or a war room, which is a dedicated room for following up projects. Set-based design is discussed, which is some sort of approach where you have several competing alternatives developed in parallel based on some preliminary aims, and then you deselect successively and then pick the final solution rather late. So several alternatives are competing to become the final product, let's say. There's a discussion about prototypes and beta testing, beta versions, digital models, and also some generic product development tools like quality function deployment, QFD, which tries to make sure that technical product characteristics fulfill customer needs. Design for manufacturing and design for assembly is discussed also in this chapter. And then you have also the failure mode and effect analysis, which is the FMEA, which is also a generic tool that's very commonly used within industry, within product development projects. So just a few examples. Here's an example of visual planning, which is from your course book, where you try to visualize how different product development projects are currently at which stage they are, and what's going well and what's not going well in the product development projects. Quality function deployment, QFD, works basically this way, that you have customer requirements or customer needs here, and then you try to match these with product qualities or functionalities or characteristics here. So you try to make sure that you cover the important customer requirements with good product qualities or quality characteristics of the product here. You can also take a look at how your product is competing with other competitors' products at the market, and do a comparison with this. So it's a qualitative tool for developing new products within companies. So this chapter, so a summary of this chapter is that we talked about the strategic level, the tactical level, and the operational level of product development. In order for you to fully grasp this, of course, you need to read the chapter, and I hope you will find it interesting, especially since you, as who will become an engineer, will probably work in some way or another, work in connection to product development during your career as an engineer. And with that, I want to thank you for your attention during these 4 videos about the value creation system. I wish you best of luck with your studies, and I hope you read the chapters also, and good luck with your studies and with your assignments. Take care, and bye bye.